Welcome to a deep dive into the world of quantum AI. We're breaking down what it means for industries, getting into the practical stuff. And we've got this super interesting research paper, it just came out of AI 2024, called Forging the Future. And Chase, they really get into it.
Yeah, it's wild. This tech feels like something out of a sci-fi flick, but companies are actually using it right
Yeah,
now,
so
solving real problems. It's amazing.
it really is something. But before we go too far, let's just make sure we're on the same page, basics and all that.
Right, of course. Little quantum mechanics 101 never hurts. So picture this. Instead of a light switch on or off, right, it can be both at the same time, like superposition, a qubits, like superpower.
Okay, I'm trying to wrap my head around this. So it's like, say, in a video game, a character walking through walls, A and D, grabbing a power-up at the same time.
Exactly.
Wild. But how does this superposition actually help solve real-world problems?
Okay, imagine you're trying to find the best route through a city. Millions of cars, total gridlock. A normal computer, it's got to try each route one by one, right? Stuck in traffic the whole time. But a quantum computer with superposition, it can explore all the routes at the same time, like instantly finds the best way to go.
So it's like what, a superpowered GPS for crazy complicated problems?
Exactly.
And this isn't just theoretical, right? The paper mentions Volkswagen used this to, actually optimize traffic flow in Beijing.
Exactly. They used something called quantum annealing, a specific type of quantum algorithm really good at these optimization problems. They simulated like millions of cars, the whole city, and figured out how to reduce traffic and travel times significantly.
That's incredible. So it's not just some future tech, it's happening now. And it's not just traffic, Biogen, they're using quantum AI for drug discovery, right?
Yeah, Biogen's doing something really interesting. They're using quantum computers to simulate how molecules act. It's really complex, but it's super important for developing new medicines.
So instead of just testing thousands of things in a lab, they're using these quantum simulations to see how different molecules will work, even before they make them.
Exactly.
Talk about a game changer. And JP Morgan Chase, they're using it for financial modeling, right? Like trying to predict the stock market or something.
Well, maybe not predict, but they're analyzing market trends and risks at a whole new level.
So smoother traffic, new medicines, maybe even a more stable stock market, all thanks to quantum AI. This is pretty amazing stuff.
Yeah.
But the research paper also talks about some companies that didn't have such a smooth ride. They kind of stumbled with quantum AI. What happened there?
Yeah, it's not all sunshine and roses. Some companies thought it was a magic bullet, overestimated what quantum computers could actually do, especially at this stage.
So it's not like you just flip a switch and boom, all your problems are solved by a quantum computer.
Definitely not. It's still early days. Understanding where this technology really shines, that's key.
Okay, makes sense. What other pitfalls did the research mention?
Well, another thing was misunderstanding the hardware. There are different types of quantum computers, each with their own strengths and weaknesses. It's like any tool, you got to use the right one for the job.
You can't use a hammer to fix everything.
Exactly. And then there's the software side of things, which is just as important, if not more so. Quantum software is incredibly complex. Some companies, they underestimated the challenge of building and optimizing these algorithms for quantum computers.
So you can't just, take your old code and run it on a quantum computer.
Nope, not at all. It's a whole different ball game. It's like, I don't know, trying to run a modern phone app on one of those old school game consoles. The way it all works underneath is totally different. You need people who really get this stuff, quantum software, and it's changing all the time, super fast.
Sounds like you could really go wrong if you're not careful. Lots of ways to mess up.
Absolutely. One of the biggest takeaways from this research, from this paper, is the importance of the team. You need the right people, quantum physics people, the AI folks, the software developers, got to have them all, and they got to be able to talk to each other, bridge the gap between the theory and actually making it work in the real world.
So it's like building, what, like a super team, like in the comics.
Yeah.
Each person with their own superpower.
Yeah, exactly. And they got to work together just like a super team, got to be in sync.
The research also mentioned this need for, constant learning, which makes sense. This whole field is moving so fast.
Oh, yeah, definitely. It's like, imagine you're sailing, right? But the maps are changing all the time. You're exploring totally new territory. You got to be ready to adjust, constantly learning new things. So that's investing in training, sending people to conferences, really building a culture of always be learning, always experimenting.
So you're not just learning the rules, you're figuring out how to change the rules while you play. Pretty intense. But with all these potential problems, these pitfalls, where do you even start? What can companies actually do to get ready for this whole quantum AI thing?
Well, the paper gives a pretty good roadmap, actually. First thing, figure out where you stand, assess your organization's, readiness.
Okay, so like a quantum AI checkup, what kind of questions should companies be asking?
Start with your tech setup, your infrastructure. Can your systems deal with the massive amounts of data that quantum AI uses? Do you have the computing power?
So it's more than just getting a quantum computer, it's making sure everything else can actually use it, right?
Exactly. And then there's your people. Do you have anyone who understands quantum mechanics, AI, software development, all that? If not, can you find those people or train your current people?
To make sure you have enough engineers before you try to build a rocket, right?
Precisely. And speaking of rockets, you're going to need partnerships. Really important for this quantum stuff.
Right, the paper talked about these collaborative ecosystems. What did that even look like?
It means talking to universities, research labs, even other companies. Sharing what you know, sharing resources, sharing the risk too.
So it's more like a rising tide lifts all boats kind of thing.
That's it. And don't forget about collaboration within your own company too. Get everyone talking to each other, the quantum people, the AI people, the data people, everyone.
Break down those walls, get everyone on the same page. It sounds like the companies that are really nailing this quantum AI thing, they're the ones who got this whole open collaborative thing. But what about startups? They don't always have the same, deep pockets as the big guys. Can they even play in this quantum AI world?
That's a great question, and honestly, one that deserves its own deep dive.
Startups, quantum AI, it's like David and Goliath, right?
Huh?
But can they really compete?
You'd be surprised. Startups, they've got some tricks up their sleeves.
Okay, I'm listening. What kind of tricks?
Well, first of all, they're fast, agile. Like, picture a speedboat, right? Big old cargo ship trying to keep up. Startups, they don't have all that baggage. They can change direction quickly, try new things. That's huge in a field like this. Everything changing so fast.
They can kind of zig and zag while the big guys are still turning the ship.
Exactly. And they're not afraid to take risks, which kind of goes with that speed. Startups, they're more likely to say, hey, let's try this crazy idea. What's the worst that could happen? They're not answering to a board of directors. They can move fast and break things.
Yeah, like those explorers, just setting sail into the unknown. No map, no guarantees.
That's a good way to put it. And the last thing, startups, they're focused, laser focused. They've got one problem they're trying to solve, one mission, and a small team that's all in on that mission.
So they're not trying to boil the ocean, they're just trying to make the perfect cup of coffee.
That's it. But it's not all easy street for startups, of course. They need money, they need the right tech. Sometimes it's hard to find the people with this very specific expertise.
So how do they do it? How do they compete with the big guys who have all the resources?
Partnerships, that's going to be key. Startups got to find the right collaborators, universities, research labs, even those big companies we were talking about. It's about leverage.
So it's not just about what you have, it's about who you know, who you can work with.
Exactly. And never underestimate the power of that agility, that focus we talked about. Startups, they can move faster, get new solutions out there before the big guys even finish their meeting.
It's exciting to think about, these little guys coming in, changing the game. This whole field of quantum AI, it's still so new, anything could happen.
Absolutely. And that's the thing to remember. Whether you're a big company or a startup, this is just the beginning. We're at the very start of something incredible.
So what's the one thing our listeners should take away from all of this?
The quantum AI revolution is here. Now is the time to get in the game. Figure out where you stand, build the right team, never stop learning, and don't be afraid to embrace the unknown because this technology, it's going to change everything.
And if you're a startup out there listening to this, don't be afraid to dream big because the future of quantum AI, it's being written right now.
Well said. It's an exciting time to be a part of this.
It really is. And listeners, we hope this deep dive into the world of quantum AI is giving you some things to think about. Until next time.